Hello everyone! Welcome to Teacher Hanji's channel. For today's tutorial, we will recall the lessons about laws of exponents. And we will also discuss an expressions with zero and negative integral exponents. For our objectives, we have first, recall the different laws of exponents. Second, apply the laws involving integral exponents to zero and negative integral exponents. And third, we will simplify expressions with integral exponents. But before that, let us recall first what is an exponent. Remember, an exponent gives us a very convenient way of writing very large and very small numbers. And the exponents of a number says how many times a number will be multiplied by itself. Aside from exponent, we will also deal with integral exponent. So what is an integral exponent? It means the exponent is a whole number that is an integer. Meaning, in integral exponent, the exponent should be positive and it is an integer. That's why it's called integral. So take a look at this expression, a to the m power. So a here is what we call the base, while m is our exponent or the power. So let us try to simplify the following expressions. Number 1, 4 raised to 3 or 4 cubes is equal to 4 times 4 times 4, in which we will multiply 4 3 times. So that is the meaning of exponent. So we have 3 4s here, and 4 times 4 times 4 is equal to 64. Next, number 2, we have 2 raised to 7. So it means we will multiply 2 to itself 7 times. So we have 2 times 2 times 2 times 2 times 2 times 2 and times 2, in which we have here 7 2's. And the product of this one is equal to 124. Example number 3, we have 5 to the 5th power. So we have 5 times 5 times 5 times 5 times 5, which is equal to 3,125. So let us try number 4. Negative 7 raised to 4. So in this case, negative is not included since it is not written inside the parentheses. So meaning, we just multiply 7 4 times excluding the negative sign. So we have negative times quantity 7 times 7 times 7 times 7. And the product of 4 sevens here is equal to 2,401 times negative. That's why it becomes negative 2,401. So let us have the last one, number 5. This time it is written inside the parentheses. So we have quantity negative 7 raised to 4. So it means we will multiply negative 7 4 times to itself. So we have negative 7 times negative 7 times negative 7 times negative 7. And the product is equal to positive 2,401. See, if that is not written inside the parentheses, then the answer should be negative 2,401. And since for number 5, negative 7 is inside the parentheses, meaning it is included. Therefore, our answer becomes positive. Now, let us discuss the different laws of exponents that you've learned when you were in 7th grade and 8th grade. So the different laws of exponents or the rules of exponents are, first, the product rule, second, power rule, third, power of a product rule, fourth, quotient rule, fifth, power of quotient rule, sixth, zero exponent, and last, the negative exponent. So let's start discussing first with the product rule. according to the product rule, the expression should have the same base. So from here, we have here base A and base A for the second expression. And if that is the case, then we will simply add the exponent. So the answer will be copy the base and add the two exponent m plus n. So let us have the following examples. Number 1. We have here x squared times x cubed. So meaning, we will copy the base, which is x, and simply add the two exponents. So we have 2 plus 3. And 2 plus 3 is equal to 5. That will be the exponent of our base x. And this is the answer. Let us have the second example. 2 cubes times 2 to the 4th power. So we have here same base. Let us just copy the same base and add the exponent. So we have 2 raised to 3 plus 4. And 3 plus 4 is equal to 7. That will be the exponent of 2. Which means 2 raised to 7 is equal to 128. So let us have a last example. We have 2y times y cubed. So in this case, we will just get the same bases. Since 2 is not included to this one, we will put that outside the parentheses and combine the expression with the same base. So we have 2 outside the parentheses and the exponent of y here is 1, while the other one is 3. Just add the two numbers. Next, if we simplify this one, that one will be equal to 2 times y to the 4th power. And this is the answer. So let us move on with the second law, which is the power rule. In power rule, the expressions is written inside the parentheses, in which there is exponent outside the given parentheses. So in order to apply the power rule, we will simply distribute the exponent outside the parentheses to the expressions inside the parentheses. Therefore, from this example, we have quantity A raised to m times raised to n is equal to A raised to product of m and n. So let us have the following examples. Number 1, quantity m cubed raised to 4. So from here, we will distribute 4 inside the parentheses and multiply the two exponents. So we have m raised to 3 times 4. And 3 times 4 is equal to 12. Therefore, the simplest form of this one is equal to m raised to 12. Let us have another example. We have quantity 3 squared raised to 3. So again, we will distribute the exponent 3 inside the parentheses and multiply it to the exponent that is written inside the parentheses as well. Therefore, we have 3 raised to 2 times 3. And 2 times 3 is equal to 6. Therefore, we have here 3 raised to 6. And 3 raised to 6 is equal to 729. So let us move on with our last example. We have quantity n raised to 4 raised to 5. So the same, using power rule, we will multiply the two exponents. So we have n raised to 4 times 5, which is equal to n raised to 20. Let us now move on with our third rule, which is the power of product rule. So it states that if there is exponents outside the parentheses of the given two expressions, we will simply distribute that exponents to the expressions written inside the parentheses. So example from here, we have quantity A raised to m times B raised to n raised to x, which should be equal to A raised to the product of your m and the exponent outside the parentheses times b raised to the exponents of your b and the exponent outside the parentheses, which is x. So let us check the following examples. Number 1, quantity m times n squared raised to 3. Therefore, we will simply distribute 3 to m and n here. Therefore, we have m cubes times n raised to 2 times 3. If we simplify this one, the answer will be m raised to 3 times n raised to 6. And this is the answer. Let us have the second one. We have quantity 7x squared times y raised to 4 raised to 2. Applying the power of product rule, we will simply distribute 2 to the expressions inside the parentheses. So we have 7 squared x raised to 2 times 2 y raised to 4 times 2. So let us simplify this one. 7 squared is equal to 49. And x raised to 2 times 2 is equal to 4. Y raised to 4 times 2 is equal to 8. Therefore, the simplest form will be 49 x raised to 4 y raised to 8. Next, last example, we have quantity negative ABC cubed raised to 4. So the same, we will distribute 4 to the expressions inside the parentheses, including negative 1. So we have quantity negative 1 raised to 4, A raised to 4, B raised to 4, and C raised to 3 times 4. Simplifying that one, the answer will be A raised to 4, B raised to 4, and C raised to 12. What happened to this one? Since multiplying negative 1 to itself 4 times give us positive 1, that's why these expressions become positive. No need to write positive 1 here. So let us have our fourth law, which is the quotient rule. And the quotient rule states that if A raised to m over A raised to n, then the simplest form will be A raised to m minus n. So meaning, in quotient rule, we will simply subtract the two exponents with the same base. Let us have the following examples. Number 1, f raised to 7 over f squared. So they have the same base here, f and f. Therefore, let us simply subtract the two exponents, copying the base. So we have 7 minus 2. And f raised to 7 minus 2 is equal to f raised to 5. So that is the quotient rule. Another example, 2 raised to 5 over 2 raised to 3. So since we have here same base, then let us subtract the two exponent. We have 2 raised to 5 minus 3, which means it is equal to 2 squared. And 2 squared is equal to positive 4. Last example, let's have 8h raised to 5 over 4h raised to 10. Since we have here numerical coefficient 8 and 4, let us separate it from our variables. So we have 8 over 4 times 1 over h raised to 10 minus 5. Why in the denominator? If you notice, the exponent in the denominator is greater than the exponent in the numerator. Therefore, to avoid negative exponent, we will subtract 5 to the 10 in the denominator. That's why we have it this way. And 8 divided by 4 is equal to 2. 2 times 1 becomes positive 2. That's why it's our numerator. And 10 minus 5 is equal to 5. That's why it is our exponent to the denominator. So the answer is 2 over h raised to 5. So let's have our fifth rule, the power of a quotient rule. So in power of quotient rule, we have this example in which we have a over b raised to m, in which the exponent is outside the parentheses. So we have a raised to m over b raised to m. So let us have the following examples. Number 1, so we have quantity 3 over w raised to 3. So let us distribute 3 to our numerator and 3 to our denominator. So we have 3 cubes over w cubed. Simplify 3 cubes, we have 27 over y cubed. So this is the answer. Another example, we have x cubed over y raised to 4 raised to 5. So let us distribute 5 to our numerator and our denominator. We will also apply the power rule here. Therefore, we have x raised to 3 times 5 over y raised to 4 times 5. So let us simplify the exponent. We have x raised to 15 over y raised to 20. And that is the answer. Let us have the last one. We have negative 3a squared over b. So the same, let us distribute 2 to the expressions in our numerator and denominator. So we have quantity negative 3 squared, a raised to 2 times 2 over b squared. Simplifying the numerator, we have 9a raised to 4 over b squared. And this is the answer. Let us have our sixth rule, which is the zero exponent, in which it says that if a, or the base, is raised to 0, then the answer is equal to 1. Let us have the following examples. Number 1, 9 raised to 0 is equal to 1. And b raised to 0 is also equal to 1. How about 100 raised to 0? That is still equal to 1. Even if that is 1,000 raised to 0, 1,000,000 raised to 0, they are all equal to 1. How about this one? X, y raised to 0. And this one is equal to x. Why? Because the exponent 0 is for y only. Therefore, y raised to 0 is equal to 1 times x is equal to x. What if there is a parenthesis at x and y, in which we have quantity x, y raised to 0? So from this case, this one now will be equal to 1. Last example, we have ab raised to 0 times c. So this one is equal to ac. Why? Because the exponent 0 is intended for the base b, excluding a and c. Therefore, if we simplify this one, the answer will be ac. Remember that in zero exponent, any number excluding 0 or the base should not be equal to 0 with an exponent of 0 is equal to 1. Let us have our last law, which is the negative exponent. So you see from our example, we have here a raised to negative n is equal to 1 over a raised to n. If you notice, the exponent here from negative becomes positive after getting the reciprocal of the given expression. So let us have the following examples. Number 1, we have z raised to negative 3. Let us get the reciprocal of this one. We have 1 over z raised to 3, in which the exponent from negative becomes positive. Let us have another one. We have 4 raised to negative 4, which means that is equal to 1 over 4 raised to 4. And let us simplify 4 raised to 4. We have 1 over 256. Another example, let's try 4 times x raised to negative 7. Since the exponent negative 7 is intended for our x only, then let us get the reciprocal of x raised to negative 7. That's why the answer will be 4 over x raised to 7. Now, let us try to simplify the following expressions. Number 1, we have 3 squared times 3 cubed. So, using the product rule, the answer for this one will be 3 raised to 5. We simply add the two exponents since we have here the same base. So 2 plus 3 is equal to 5 and 3 raised to 5 is equal to 243. Number 2, quantity negative 2 raised to 6. So this one is equal to 64. It becomes positive because if you multiply negative 2 6 times to itself, the answer becomes positive. Let's try number 3. We have quantity p cubed over q raised to 9 raised to 2. So applying the power of quotient law, so we have here p raised to 3 times 2 over q raised to 9 times 2. Which is equal to p raised to 6 over q raised to 18. Number 4, 10m raised to 11 over 8m raised to 7. So this case, we will use the quotient rule to get the answer. So first, let us simplify 10 over 8. So we have 10 over 8 times m. Let us subtract the exponents. So we have 11 minus 7. And the simplest form of 10 over 8 is equal to 5/4. And 11 minus 7 is equal to 4. Therefore, the answer will be 5m raised to 4 over 4. Let's add number 5. Quantity 3x cubed, y raised to 4 raised to 2. So in this case, we will use the power of product rule. So let us distribute 2 to each expressions inside the parentheses. So we have 3 squared, x raised to 3 times 2, y raised to 4 times 2, in which this one is equal to 9, x raised to 6, y raised to 8. Number 6, try. Quantity a raised to 7 plus b squared raised to 0. Yes, this one is equal to 1 since the exponent 0 is intended for the expressions inside the parentheses. Next, last one, let's have r raised to negative 4 over s raised to negative 5. So this one has something to do with negative exponent, in which to make the exponent here positive, we need to get the reciprocal of the given expression. Therefore, after getting the multiplicative inverse of these two, we have 1 over r raised to 4 for the numerator over 1 over s raised to 5 for our denominator. Therefore, let us simplify this complex fraction by multiplying the numerator by the reciprocal of our denominator. So we have 1 over r raised to 4 for our numerator times s raised to 5 over 1 from our denominator. So simplifying this one, we have s raised to 5 over r raised to 4. So that is how we use the laws of exponents in simplifying the given expressions. That's it for our video. Thank you for watching. See you again in my next video. Bye!